In this video, I'll teach you what are slices in Golang. In this video, you'll learn how to declare them, how to use them, about slices standard package which was introduced in Go version 1.21, and how to use append function from A to Z about slices. So let's get started. In short, slices are just like arrays. Array is of fixed length and slices are of dynamic length, which means you can store as many elements as you want in a slice. Great, right? But the point is that slices points to an array.
You get right, yeah?
Okay, let me explain. When you create a slice, internally an array will be created and slice points to that array. So when you change the value in the slice, the underlying array will also be changed. Okay, now let's declare a slice of integers. To do this, we have to write slices colon equal to, you can choose whatever the notation you like, but I prefer Walrus operator. Square brackets, an integer and flower brackets. Now this becomes a slice of integers. If you write any number in the square bracket, let's say 5, now this becomes an array of 5 integers. There is one more way to create a slice, which is using make function. Using make function, you can create slices, channels, maps. Don't worry if you don't know what are these channels and maps. Please drop a comment if you want me to make a video on them. I'll write make slice of integer and the initial length of the slice. Now you might be confused. Slices are dynamic and why we have to specify the length. This is the initial length and make function expects it. And the size of this slice can grow. And the next number is optional. This is the capacity of the slice. If I write 3, 8, now what will happen under the hood? Now array of size 8 will be created and from that 3 blocks are assigned to the slice. So the length of the slice becomes 3 and capacity becomes 8. You can check by using length and capacity functions in Go. I'll write fmt.print len of slice and cap of slice. Len function and cap function are going to calculate length of the slice and capacity of the slice. If I run this program by go run main.go, look, we got 3 and 8. 3 is the length and 8 is the capacity. Okay, now how do we insert the elements into the slice? Okay, I can understand people who are watching this video are already aware of all this stuff, but just give me 1 to 2 minutes, I'll complete this. If I write slice of 0 equal to 3, this is going to insert element 3 in 0th position. So can I write slice of 3 equal to 2 or slice of 4 equal to 5? We have capacity of 8, right? Can we do this? The answer is no. If I run this program, we got index out of range error. So we can insert the elements till the length of the slice. Then how do we utilize those remaining 5 empty positions? So this is where append function comes in. Append function appends the given number to the slice. If I write append of slice, 6, append function appends this number 6 to the slice and returns a slice. If I write slice equal to before, now this slice will be updated. Now I got some crazy idea. Instead of updating the same slice, what happens if I use different slice? I'll just uncomment the above slice declaration. I'll rename as slice 1. I'll write slice 1 here. Now let's try to print. I'll write go run main.go. Look at the output. Okay, number 6 was appended to this slice. I think this is self-explanatory. So append function appends 6 to this slice and it returns that slice. And this slice was updated with this slice. Now let's check what happens if the elements in the slice has reached its capacity. I'll copy this append statement. I'll paste 3 times. So now there are total 8 elements in this slice. So what happens if I paste this line one more time? I'll print this slice. I'll run this program go run main.go. And this worked. Let's check the capacity of the slice. I'll write cap of slice. I'll run the program go run main.go. It shows 16. So what is happening here when the capacity of the slice is reached? Go doubles the size of an underlying array and allocates a new memory location. How do I know that? How to confirm this? To confirm this, let's try to print the address of the first element of the slice before and after the capacity reached. I'll write fmt.printf %p, slice. This prints the address of the first element in the slice, which means address of the underlying array. If I copy this statement, if I paste here, now if I run this program, look at the output, both addresses are not same. This confirms when the capacity of slice is reached, Go doubles the size of the underlying array and allocates a new memory location. I said the meaning of this statement is the address of the first element in the underlying array, right? I can also write, I'll copy this statement, I'll paste here. If I write address of slice of 0, this also means address of the first element in the underlying array. Both gives the same output. This is because no matter what language you choose, address of the array is the address of the first element. Do you think is that true for slices as well? I want you to comment the answer. Now we have learned something about slices. Let me clear everything. Now I'll declare one slice of integers. I'll put 1, 2, 3 numbers. This is a syntax to assign elements while declaring. Now I'll assign this slice to another slice. Now if I change slice 1, slice 2 will also be affected. Why? Because both slices point to the same underlying array. So how to solve this kind of problem? So there are 2 ways to solve this problem. First method is to use copy function. this function expects two arguments. First is target slice and next is a source slice. Main problem with this function is that you have to specify the length of the target slice. If the length of the target slice is less than the source slice, this will not work. Now if I try to change one slice and if I print both slices, look at the output. I got different results. And the second method is to use the clone function from the slices package. This is somewhat easier and preferred method when compared to copy function. I'll write slices dot. Look how many functions we have in this slices package. From these, I want clone function. This clone function expects a source slice and returns a copy of it. I'll store this copy in slice 2. When I run this program, look at the output. Both slices have different values. Okay, now let's look at the most common operations that we perform on the slices. Most of the operations are present in this slices package only. When you want to check two slices are equal or not, you can use equal function from this slices package. This equal function expects two slices and returns a boolean value true or false, whether they are equal or not. The next most important method is when you want to sort the given slice, there is a sort method in this slices package. You simply have to write slices.sort. This method expects a slice and doesn't return anything. The sort function sorts the given slice in ascending order. If I run this program, all the numbers are in ascending order. If you want to sort in descending order, then instead of using sort function, we have sortfunc function. This method expects a slice and a comparator function. The working of this comparator function is similar to how it works in many languages. First of all, it compares any two values in the slice. If the result is less than 0, then x should come before y. If it is equal to 0, that means both are equal. If it is greater than 0, then x should come after y. If I save this file, when I run the program, look, the slice is in descending order. In some cases, you might require subslice in a slice. That means you might require a slice from one index to some other index. To do this, you don't need any method from the package. Let's say, for suppose, if you want a slice from second index to fifth index, you have to write 2:6. You'll get a subslice from second index to fifth index. Last number was not included. If you want from 1 to 7, you have to write 1:8. If I run this program, look, I got a subslice from second index to fifth index. You know how to insert an element in the slice, right? But do you know how to delete an element from the specific position in the slice? Again, there are two ways to do this. For suppose if I want to delete a second element, which means a first indexed element, first method is, just now I have explained how to get a subslice, right? The idea is that I'll concatenate two subslices. One is from 0 to that index to be removed, and second is that element next to that index till last. So how to concatenate? We have our append function, right? Append function expects two arguments. A first argument is slice and next argument is elements to be appended to the slice. That means you can append as many elements as you want to that slice using this append function. For example, if you want to delete this fifth element from this slice, which is fourth index, now I'll write 0:4. We have already discussed that fourth indexed element will not be included, which means this is going to return a slice from 0 to third index. For the next argument, I'll write 5:, which means this returns me a slice from fifth index till last. If you don't mention second number, it means till last. If you don't mention first number, it means 0 by default. I'm getting error. This is because the second argument I have passed is a slice. An append function expects elements to be appended to this slice. If I put 3 dots after this slice, then the error is gone. The name of this 3 dots is a spread operator, and the job it does is to convert a slice of elements to elements. For example, here the spread operator picks each element from the slice of integers from fifth index and places to the append function. And that's why it didn't throw any error. So the meaning of this line is, to the slice from 0th index to 3rd index, we have skipped the 4th index. We are appending all the elements from 5th index. When I run this program, in the output, 4th index is missing. In this way, we can delete any element from specific position. And the second method is we can use the delete function from the slices package. I'll write slices.delete, and this function expects a slice and from which position to which position you want to delete. For example, if I want to delete from 1st index to 5th index, I'll write 1,6. Here also 6th index will not be included. Deletion goes from 1st index to 5th index. So this delete function returns the modified slice. If I collect that slice, if I print the slice, look at the output. This function deleted elements from 1st index to 5th index. Sometimes you want to reverse the slice. For that we have slices.reverse function. This reverse function does not return anything. It manipulates the slice internally. Some functions return some things and some other don't. Just hover and learn what this method does. Just keep practicing. This reverse function obviously expects a slice. If I run this program, look at the output. Slice was reversed. Sometimes you want to get the index of a specific element in the slice. For that we have slices.index. It expects slice and an element for which you want to find the index. If you have duplicates, it returns the index of a first occurrence of that element. If I run the program, look, we got the index of the given element. If the given element is not found, it returns -1. Sometimes you want to insert the elements in a specific position in the slice. You guessed it correctly. For that we have slices.insert function. This insert function expects a slice and to which index you want to insert and what element you want to insert. For example, if I want to insert element 89 at first index, I'll write 1, 89. This function returns a slice. If I run this program, look, 89 was inserted to the first index, moving the slice to the right. These functions I think are most used while working with slices in Golang. Okay, that's it for this video. I hope you liked it. Please let me know if I explained anything incorrect or you faced any difficulty while watching the video. Please support me if you like my content.